Hey, psyched to be here with Richard Edwards, an actual IoT expert, unlike me, who's just kind of guessing and poking around in the dark. Richard, welcome to the show.
Thanks, Nick.
Yeah, super psyched to have you on. So we met through, you've got a YouTube channel explaining kind of radio concepts in general to folks, and you had seen mine and said, hey, here's a guy who looks like he's super enthusiastic about this, but maybe doesn't have this expert background. Let me see if I can help him out. And that's how we came to start talking.
Yeah.
So give the folks who are listening an idea of where you're coming from. Where's your background? What do you do for work? Tell me about your life.
Yeah, sure. Well, I'm from Manchester in the UK, and I've been working in telecoms for way too long, kind of 25 years, but all in the kind of radio environment. So planning where masts would go, optimizing their configuration based on people's uses, and performance aspects as well. So not just tweaking stuff, but looking at statistical analysis and see if you can find out faults or ways to improve the network. And I've been doing that for 20 years really.
And is that IoT specific, or is that kind of cell stuff and phones, or a blend?
A blend from everything. That started out with 2G and then rolled out 3G, 4G. Not done any 5G stuff, and then IoT, and then smart metering at the moment.
Okay. And that's what you do for work, is you help out with, I think it's like M2M, something like that?
Yeah. I've done, I rolled out the first M2M network in the UK pretty much on my own.
Okay. And M2M, for folks who aren't familiar with it, is machine to machine, and that's kind of...
It is, yeah.
And correct me if I'm wrong, or help me understand that. Is M2M and IoT are basically two ways of saying similar things, or are they actually very different?
I think they're pretty much the same thing.
Okay.
I think maybe IoT is one way of saying it's an M2M thing, but as far as I'm concerned, it's the same thing.
Okay. And when you say you rolled out this IoT network, or this M2M network in the UK, what was the scope of that? Was that a couple stations? Was that a couple million? What did that look like?
Well, to begin with, it was the top kind of 10 cities. So the biggest cities in the UK. So obviously London, Manchester, Glasgow, for those who might not know the UK very well. And it was a case of rolling out coverage for indoor coverage, not outdoor, indoor coverage across all of those cities. And we had about 150 sites across those areas, kind of about 50 in London, and 100 in the rest of the cities, and that provided wide scale coverage. And the aim was to then roll that out to the whole of the UK, which was about 1,500 in total. But we didn't do that in the end.
Not yet. Now, is that running on the same frequency that the Helium stuff is on? Is that on 868, or is that on something different?
Yeah, that's right. They're all on the unlicensed 868 band. So obviously 915, I think, over your way. But yeah, yep. 868, yeah.
Okay, cool. So I think that gives a pretty good background, is that you've done this for a long time. It's very likely you know what you're talking about. Pretty believable. So let's start with the piece is let's start at the very beginning. What are the ways that Helium is incentivizing deployments that are at odds with a typical IoT kind of gateway deployment?
Well, I think that Helium is incentivizing kind of line of sight coverage. It's incentivizing financially people to just put out a miner and provide the biggest load of coverage that they can. And where that's fine now, because as with any kind of cellular technology network, you want to get the most coverage you can to begin with. In future, when we're using devices, and I would guess that the more financial thing for Helium will be that the finances will be driven by the data from devices. That's a bit of a problem because it's a totally different scope.
Yeah. And I think that was one of the very first comments that I saw you putting on the YouTube, is that I've said like, hey, just go ahead and put a low gain antenna. It won't make a huge difference. I think that advice was much more correct prior to the POC V11. And you had come on and said, look, I've rolled out 100 of these things. We put high gain on every one of them. You don't lose anything. You should put a high gain as the standard. So yeah, go ahead and walk me through that correction.
I mean, when we were looking to roll it out, as I said, we were looking at light indoor coverage rather than deep indoor coverage. And that's because we suspected that most of the use cases of the devices would be mainly indoor. As it turned out, that was the right assumption. So a lot of our sites were quite big. Obviously, when you're rolling out for a corporate kind of scenario, you want to build the fewest masts and get the greatest coverage. So we're trying to get sites that were quite high up.
Yep.
So I think we had a minimum 15 meters, maybe 20, and they went up to I think one in a city called Liverpool on the top of their cathedral was 100 meters, but generally we wouldn't go higher than 60 meters. And in order to get general coverage, we had to have high gain antennas, and the link budget that we calculated was based on an 8 dBi antenna gain. But when we kind of did drive testing, which takes measurement samples from our test devices, we found that the coverage was perfectly fine. And in the likes of London, I said there were 50 sites. We were getting kind of coverage outside in really kind of canyons of buildings in London. So, and this was 50 sites. And I don't know if you know, but London's actually one of the biggest biggest cities in the world. I think it's bigger than any other American one. So it's a big place to have 50 sites.
Yeah.
So, yeah.
So with 50 sites, you're able to cover all of London.
Yeah, that's right. Yeah. And that's to like an outdoor level and light indoor coverage. Because you're expecting, obviously, propagation loss, a certain amount of loss associated with going into buildings. So we still, plan to get that indoor coverage. And that was with high gain antennas. Even with lower buildings, be they like 15 or 20 meters, every single site had the same antenna on it.
Okay. And I guess the general kind of takeaway there is that there's no, from your perspective, rolling this out as an actual network, and for folks who've done the math on this, there's no real problem with overshoot, which was what, those of us who are brand new to radio frequency and high gain at the very beginning thought like, oh, if we have a high gain antenna, sure, it'll go far, but it'll overshoot by miles, everything around it. And it turns out that unless it's really high, it's going to hit the ground within like 300 meters, something like that.
Yeah, that's right. I mean, I've seen all the kind of the diagrams that people have done online where you get these kind of cones of coverage that get narrower and narrower as the antenna.
Yeah, no, guilty as charged.
Well, no, I mean, it's fine, but the actual antenna radiation patterns don't look like that. As you get a higher gain, you still get these areas of coverage or lobes to the sides, to the back. And although obviously they're a lot lower in signal, the fact is, if you've got line of sight, then that drop in signal level of 10 dBs or 30 dBs or whatever doesn't stop you from getting coverage. Certainly, if you've got other miners with line of sight, external antennas at high gain, it's not realistically going to be a problem.
Right.
What I would say, though, is, if it's really, really, if it's high up, 60 meters, 50 meters, or whatever, say someone's apartments, then, you will benefit from having more of a gain going down towards the lower level properties, in which case you should get a high gain antenna with some electrical tilt. Standard antennas just have zero electrical tilt, whereas, electrical tilt really has a massive impact on the radiation pattern. So I would, when I get my install going, I'm going to be looking for high gain omnis with electrical tilt, but I do know they're quite a lot more expensive than standard ones.
Okay. I don't know much about this electrical tilt thing. Now, so I'm wondering, can I just take my antenna and tilt it and offset it that way, or like do the same thing that way, or is that a completely different pattern?
No, I mean, I could give you an example with kind of using a balloon analogy, which I've got down the side here.
Sure.
But essentially, kind of, if you think your kind of lobes, if I use, say, I don't know, a couple of pens or something. Yeah, let's get a couple of pens. If you think of your standard dipole antenna that kind of looks like that with your hands in the middle, if you mechanical tilt it, you just go like that.
Yep.
So obviously what that means is you get the coverage where you want it down here, but all this goes off into space, and that's not good. Whereas electrical tilt does that.
Ah, okay.
So not only have you got your coverage where you wanted it, say from your apartments to the local houses or whatever, you also got the same in the other direction. So with a high gain, then you get the best of both worlds, basically.
Okay. Where were you a year ago, dude? I was trying to learn all this stuff.
Well, to be honest, I hadn't heard of helium a year ago. And then when I started, reading up into it, I was like, why didn't I get into this a year ago? So,
Sure.
yeah.
I mean, it's been an interesting piece. I think there's folks who just got in early and who got kind of lucky to get in early, but we were, for the most part, a lot of us were just, kind of pushing about in the dark and figuring it out as fast as we could. And what I found from the gloriousness of YouTube is that there's plenty of things that I got wrong. Most of them are not wrong enough to be a huge difference. But, the experience that you and folks like you have from rolling out these deployments is going to be really helpful for the long term for the Helium network, which is, pretty cool.
Yeah. I mean, everyone who has to start out somewhere.
Yeah.
And having experience, it's all right having like uni-based knowledge and a bit of experience, but if you got a lot more experience, then it's really good. And I don't just mean as in doing one single minor. You've obviously done tons and tons of them, so you're going to get a lot more experience because of that, which is why you kind of have more credibility than some other YouTubers.
Sure. Yeah. Just you get to see a lot. Okay. So, let's go through how you might assess or choose an antenna, because people are obsessed about antennas, even though I still don't think they matter that much. Like as far as earning HNT, which is what brings a lot of people in.
Cool.
For coverage, they might make a significant difference. I don't know if it is a huge difference or if it's just kind of really small differences. But walk me through what you look at when you're looking for antenna for your deployments.
Sure. When I look at antennas, as I've done for my backup internet at home, I go online, I just search for them at different manufacturers because I don't know them all. But I'm interested in whether the manufacturer's website provides a data sheet that you can download.
Yep.
Ones on eBay certainly don't.
Right.
As a tester, I bought a cheap antenna off eBay, a couple of them to test. Sorry. And they performed poor, very poor. Whereas you buy one online with a data set, then at least you can buy it and then you can compare, with real results, whether they live up to what they claim. So when looking at that data set, I'm looking at the VSWR readings over the frequency band that you're interested in.
Mm-hmm.
I know everyone kind of says less than 2, but personally I go for less than 1.5.
Yep.
Or 1.5 if you can get it in your frequency range. That's great because that means more of the power that's coming out from your miner is going into your antenna and not being reflected back.
Right.
The second thing I'd look at is the beam width. The beam width is related to gain. The higher gain you have, the narrower the beam width. So I'm looking at those radiation patterns that I mentioned before. So I'm looking at the back lobes and the side lobes and what these funny diagrams show to see whether it kind of gives me what I want. And then, of course, the price. I'm finding that a reasonable antenna, certainly for the cellular world, is about 100 UK pounds, which I think is about $140 at the moment.
Rub it in.
Well, it's not a good rate. When I lived in the States, it was about $2 to the pound.
Yeah.
So, but yeah, that's kind of what I'm looking for. And then obviously you do kind of a bit of Googling to see whether those manufacturers are any good, whether it be RAC, be it Pointing, ASCOM, or whoever.
Yeah. Yeah. And then are you looking at the frequency band, or do you figure that a wideband doesn't, like this tune stuff doesn't make that much of a difference? Or is that pretty important for you?
When I've looked at the tune thing, I didn't think there would be that much difference looking at it. I think it was more of a kind of a, let's try and sell the helium miner thing.
Sure.
But then I did a comparison. It was actually today I was looking at one of the Pointing Omni high gain antennas. Around the 868, it was kind of around the 6, maybe 7 dBi. But then I checked the RAC one as well, and that was more kind of the 8.5 dB for the 868 band. So yeah, the tuned ones do give better results, allegedly. Obviously, you'd have to test it with some equipment to see whether that's actually true or not. But having looked at the specs and these data, that I just said, I will consider buying a tuned one instead.
Okay, cool. Super cool. And are you the kind of geek that has like a million antennas and testing equipment and all that stuff hanging around the house, or do you kind of leave that stuff at work?
Kind of guilty.
Okay.
I've got a directional antenna and omni antennas for my mobile broadband at home. It's a backup, so I've got cable here, gives me a gig, and then I've got a failover router, so if that goes down it switches over cellular, gives me about 50-70 meg using external antennas.
Okay.
So yeah, I'm a geek basically.
Good. Yeah, that's why you're here. I like it. So you've got miners basically in the mail, like these Helium miners in the mail coming to you.
Yeah, I haven't got mine yet. I'm toying with do I buy it direct and wait my 6 to 12 months, or do I get one off Facebook Marketplace or eBay? And I'm still kind of, getting round to it, because I think the Bobcat is about $500, something like that.
Yep.
With the 12-month wait, but get it on eBay, and here you're looking at about £650, so $750 to $800. So it's like, do I pay out just to get it now, and get it the payback with the earnings? So and I haven't decided whether to get like which one to get yet.
Okay,
but very soon.
Cool. There's let's see. Have you heard of this Pirate DAO with Jeremy Rollinson?
No, I haven't. No.
That might be something to look into. And then there's another one called Miner Match, but they both do very similar things where they find folks with locations and they match them with people who have hotspots. So if you have a good location, those two are great ways to, you say like, hey, I've got this location, let's split the earnings, and you've got the hotspot, and that way you both de-risk a little bit.
Yeah, that's cool. Yeah,
something to look into. Okay,
I will. Yeah, so definitely.
We did antennas. So if I heard it right, it was you're looking for making sure it's got a good VSWR or VISWR. And that seems to me as a layman to be basically an indication of quality. That's like my first thing is like, okay, if it's under 2, it's probably okay. If it's down in like the 1 to 1.5, it's probably excellent. And then a data sheet to back that up so that you know they're not just writing a number on a piece of paper, which they may be doing with a data sheet, but at least they put the effort into a data sheet.
That's right.
And then, so after VISWR, it goes, then you're looking at gain.
Yeah.
And you're making sure I'm guessing, is that like between like say 6 and 12 or something?
Yeah, I'd say, if you're not going to go for the higher gain ones like the 9 and you're a little bit concerned, then yeah, I would say 6 to 9. Yeah.
Okay. And then you look for electrical down tilt for a lot of your locations because you probably have the higher ones. Is that right?
Ideally, yeah. But I've not really found a lot online. Not done that much searching, to be fair, apart from the professional ones like 𝐴SCAM or CommScope. And when I looked at one of them, it was $1,000. But I'm sure if you searched, you could get one for much less than that. But the point being, it would be multiple times what you'd currently pay out for. But it would be worth it in the end.
Yeah. Yeah, no, I guess it's worth it if you got a great location, and that's really the thing that makes the most difference is location.
Yeah, of course it does. Yeah, antennas are one thing. It's great having low VISWR, but if you've got a poor location, you're not going to do now.
Yeah, if you're down in the valley, it doesn't matter. You can have the fanciest antenna in the world. They don't push through a mile of earth. They just don't. That's a whole different frequency. Let's see. So the next thing then would be kind of the connectors and cables pieces. Talk me through how you think about that.
It'd be surprising just how much loss you get from cables. When I was testing them for my cellular, I tested some really poor quality ones up to LMR 400. I know that's very popular at the moment, but I'd already been looking at it. And the difference in internet speeds, for example, are massive from doing those cables. So it really does make a big impact in terms of the loss.
Huh.
So, ultimately, with RF, you want to get as much power from your miner coming radiating out of your antenna, obviously. But with the cables, I'm ultimately just looking at low loss. So that's it's a compromise between price and the loss of dBs per meter, generally pi in dBs per 100 meter. And also in the cellular industry, we kind of choose the cable for whatever length it is of getting no more than 2 dB loss, and to be honest, no more than 1.5. So the longer the feeder run, cable run, then the thicker the cable to get a better quality one. And It really is worth paying out. You have to, because otherwise you lose so much coverage.
Huh. So let me make sure I'm understanding that right. Is that for every cable or every kind of antenna and then hotspot placement is you're aiming for no more than, you said, sorry, 2 dB loss. What, like, doesn't matter the distance.
Yeah, that's right. Yeah. I mean, it depends, because the amount of power you got propagated depends on so many different things. It's not just the antenna and the connectors. You've got the power reflection off, obviously, the antenna, but also the radiation pattern. So it's a mixture of all those things. But in professional wise, no more than 2 dB, usually 1.5. For helium, yeah, I'd say no more than 2. But
wow.
It's the difficulty for me is that I won't be doing a long feeder run, cable run. I want to put the equipment as close to the antenna as I can. In my personal case, it's probably going to be 5 meters. But yeah, I will certainly be using the 𝗪𝗻𝗁 I've already got, from the antenna to the router, to the miner. But yeah, it's kind of the price as well. For when the application I was looking at, I was checking RG58 versus 𝗪𝗻𝗁, and the LMR was, I don't know, 4 times the price, but the improvement in internet speed was 10%, if that.
Really?
So yeah. So it's the kind of law of diminishing returns, isn't it?
Yeah.
That you can, the more and more you spend, the less and less the improvement.
Yep.
So it's that weigh up of how much do people want to spend on their equipment.
Sure.
Against,
and ultimately, is that going to make a difference in earnings performance? Because that's what drives most of these deployments, is the earnings piece.
Yeah, I think people are a bit overly obsessed. When I see all these videos, it's a real obsession about getting the tiniest amount of improvement in dB, and it's going to make you a millionaire. And it's like, well, realistically, that ain't the case. Because, I mean, you may well find people that have a different amount of earnings by changing a cable, and I'm sure there is. There's lots of other facters that affect it.
I'm sure some of them will comment in the video and tell us how wrong we are.
Yeah.
God bless them.
Yeah.
Okay, because what I had been thinking before was, and you're just going to laugh at, you're going to laugh at the ignorance, is basically you had enough. The way I thought of it was that whatever the gain was on the antenna, you could lose that in the cable, as long as you kind of kept the miner putting out what the miner's putting out. So if the miner's putting out whatever 14 over there, and you had, even if you had a 9 dB loss in the cable, as long as you had a 9 dBi antenna, not a huge deal, because you're putting out enough, or what the kind of miner was, say, planned to put out. But it sounds like from what you're saying is like, no, you don't want to go over 2.
Well, yeah. I mean, when I looked at the RG174 cable, the loss at 800 megs for that was, it was like I can't remember what it was. It was like 10 dB, and at 2600 meg, it was like 15 dB. Massive big degradation compared with 𝗪𝗻𝗁, which was like 2 dB.
Yeah.
So it's a massive difference. It really is.
Yeah, and for most folks, they're not really looking at this like what it loses at different frequency bands, because we're all in our country, and so in the US it's only 915. I don't have to look at 2700 or 600 or 860. Same thing for you. But it's neat to see as a professional where you're like, okay, well, let me look at the loss across these different frequencies. It's just cool to see.
Yeah, I mean, obviously for helium, I'll only be looking at 868 as well.
Yep.
So both in terms of loss, I mean, you get less loss at the lower frequency, so you'll get less loss for 868 using an LMR. But
Wow, super cool. Let's jump into amps and filters. Is that something where you think you're going to put an amp or a filter on every deployment, and there's a really good reason for that, or it doesn't really matter, or there's sometimes where it's like, yep, you have to do that, and most of the time where you don't?
For me, definitely a filter.
Really? Every time?
Cavity filter in my case. The reason being that one of the sites we had, I can't remember if it was around London, but one of the sites we had a problem with it. It had interference, and we just couldn't work out what it was. We pretty much stripped the site apart, moved the antenna, moved it away from the lattice mast, and in the end, we stuck a cavity filter on it, and the problem was massively reduced, and we started receiving the signals from our devices. So that's why I'll put a cavity filter on it, because you don't know. It's an unlicensed band, so you don't know what else is using it. If in the UK you go on the Ofcom website and see what other applications are allowed to use 868, there's tons of them.
Yeah.
So, and more so now with my miner, because you've got what my network was, which was Sigfox. Those sites will still be on. They'll still be transmitting, tiny amounts of data. So definitely having a cavity filter as far as I'm concerned. As for amps, I'm not sure about them. I've been reading all about that, and I'm really not sure. However, one definite use is to overcome the losses in your cables. But people are talking online about ones with like 10, 20 dB. For me, the jury's out on that one. So I couldn't answer it because I'm not sure.
Right. Now, when you look at your deployment location, are you going to be climbing up on a ladder and testing that thing and running to see what kind of signals are out there with a network analyzer? Or are you just like, hey, I'm going to put this thing up no matter what. I don't need to test it. Like, how are you thinking about that?
Well, it's an interesting one. Going back to Sigfox, the one we did, we were putting them on lattice masts and buildings and whatever. And the locations we chose were based on coverage predictions using complex radio planning tools. For my own place, though, it'll be getting it up as high as I can on my property to meet UK planning laws. So it's probably only going to be 2.5 meters higher than my roof, taken off from the chimney. But, because that's all I can do. I can't do anything else. Right. As far as other places, well, I would try and sneak some predictions in my work to have a look at what the coverage is like in different locations.
Yeah.
But the problem with planning in the UK is it'd be easy to go up to, say, a farmer and his one of his cabins or something that's overlooking a city and say, hey, can we put a little miner on your roof and we'll share the profits? And they're like, ooh, radio. That's going to cook my brain just like 5G does. 5G gives you COVID, so we're not having that. And it's like, it's a load of rubbish. It angers the likes of me and my colleagues so much that it may be a real problem for guys in the UK that then people just not interested. So there's a certain amount of marketing, if you like, to kind of convince people to do it. But I think in terms of where I would be wanting to put them, I need to do a bit more research on the best locations in terms of the finance side, because it's all right getting a great location coverage wise, but if you're not going to earn many NHT from it, then there's no point. So there's kind of this balance. Just like in cellular, you're looking where people would be using their phones. You're not going to build a mast with a load of sheep in a field. You build a mast where where the customers,
where there's people using phones. Yeah.
And that's why I keep referring to kind of the cellular world, because it's very similar, because it's still a cellular based technology, just like smart metering, just like mobile phones. They're all the same kind of idea. So there's no reason why you can't follow the same processes.
Now, is that something you think you use your connections just from having worked in the industry for so long to say, hey, I've already been on these towers. I know these people. Why don't I see if I can, get a couple miners and talk to them and be like, hey, let's figure something out.
There's certain sites overlooking Manchester that are broadcast sites for TV and radio and stuff that our company owns. And it'd be great just to sneak a miner in one of the equipment cabins, even with a really poor basic antenna, because the coverage from it would be amazing and you can't make loads from it. But I'd probably lose my job if I did that. Okay. But I know the best locations, and I know where all the masts and the buildings that have all on the mark.
Yep.
So I could go to those and say, look, this is a personal project rather than a commercial one. Mm-hmm. So it's not something I've done yet, and I've got a bit of a problem because I can't drive at the moment. But that's certainly something I will take advantage of.
You said you can't drive?
Yeah, I had to give up my license for medical reasons. I used to drive, but because I suffer from epilepsy, then they kind of don't go together.
No, they don't like that. Well, you'll wait for the self-driving cars, and then you can go wherever you want.
Yeah, Yeah.
Yeah, interesting. I bet there's someone in the UK who A, can drive, and B, has a bunch of hotspots. And that might be, I mean, I always look at this stuff like, where are the connections we have? People ask all the time, how do I get a great location? And
Yeah.
it's partly about doing the kind of technical mapping side and saying, okay, where's the high point? How do I get power there? How do I get backhaul? All that stuff. But I've found that my great locations have come from personal connections, from just knowing the people who own that land and saying, hey, can I put a miner on there? So it sounds like you've got a good 50 to 51% of that value ready to deliver. Cool. You talked about building a network for, let's see, there's a term used, light and deep coverage. Is that a technical term, or is that just how you guys think of it?
That's just kind of how we referred to it in this project.
Okay.
But
I mean, it makes sense. I just didn't want to make sure I understood the terminology.
Yeah,
And
in this instance, light indoor was just a couple of meters, from the entrance, a few meters into the entrance, whereas deep indoor is even further, so right in the heart of the building. And obviously, with propagation loss, then obviously the signal's going to be a lot lower. So if you were planning to get the deepest coverage, then you just need more sites, and that would be more money for a company.
Mm. And let's talk about this indoor propagation loss. So it's just the loss of the signal strength as it goes deeper and deeper indoors, and basically gets hit or hits more and more things, and attenuates or dampens the energy. How typically, walk me through kind of how you think of that and what you know about that.
It depends, obviously, on the type of the building. I think most people know that if you've got antennas close to glass, you don't lose as much, and that's quite right. When I did my tests at home, I was finding that the difference, say, from the router inside my ground floor and an external antenna, was a difference of 30 dB. So you can imagine what the improvement in speed that 30 dB comes from. But when we were testing these sites with our IoT, it varied, because it depends where your site was. It depends what type of building it was. Because if you've got a site over the road from really big, thick building, you're still going to get great coverage indoors. But we were looking at around 15 dB, something like that, loss for kind of 5 meters indoors. But the link budget that we had, I think it was quite a lot more. I think it was up to 25. So, but generally, I would say that.
So you were putting much higher power. Am I understanding that right, or with this link budget piece? Because I don't have a good grasp of that.
Link budget is purely kind of where you say, well, we know how much loss we've got due to kind of standard background noise. Mm-hmm. We know what loss we've got from this, from that, and we know what the minimum signal level we need to get a scrape of signal. So that's the link budget, and the difference is the most loss you can have. So you know that if you want to get a certain coverage signal out inside, you've got to have a certain amount greater outside.
Got it. Okay.
And that then determines how many sites you need, because you do your radio predictions with cover, the signal thresholds of outdoors.
Okay, yeah, that makes sense. Is that basically you're looking for a number that you need to get indoors, and then you build your site based on that number, your number of sites.
Absolutely, yeah. And it turns out that was the right thing to do, because, like I said, a lot of Helium is based on line of sight outdoor. But we found, I think, of all the customers we were talking to, all but one were all indoor applications.
Okay.
All but one. So with Helium, all kind of people want in their outdoor line of sight coverage. We go to devices and it might fall over, because, obviously it depends whether kind of Helium devices and whether different countries are similar to the UK. Who knows? Yep. But if they do turn out to be the majority indoor, then that's where the problems lie.
And it's funny, because Helium, the chain, isn't really incentivizing coverage in that way. It's just like saying put it everywhere. And there are so many of these gateways. You think about, you did this giant rollout in the UK, and it's 100 gateways all over the UK. I don't know how many are in. I don't know how many Helium hotspots are in the UK, but I'm pretty sure it's more than 100.
Oh yeah, tons and tons. You look at the density of them. I've looked at the density where I live in Manchester, and they seem just as dense as some of the the capitals in your neck of the woods. So yeah.
Yeah. I mean, it's interesting to think about this from. I'm super curious about how the professionals who maybe don't have the exposure to helium think about this.
Mm.
As far as, is there going to be, because it's so dense, is there going to be interference from all these hotspots blasting out beacons, or is that not something to worry about? Or like, what are the implications of building a network that is this dense?
Yeah, it's an interesting one because obviously only time will tell. But I've tried having a think about this, and the way helium is at the moment, it's just like the kind of the first stage that a cellular would go through. As you blast a load of coverage out, get the most you can, and then at a later stage when traffic starts coming in, then you try and optimize it by changing usually your antennas and power. Of course, helium, you won't be doing that because there are lots of individual masts rather than tons of corporate ones.
Yep.
And I do have a feeling that you might get a bit of a problem, certainly with interference. And of course, helium has a certain kind of adaptive data rate with it. And will it cause a problem? I have a feeling it might, but that's if you've got tons of devices out there. And I certainly found in my experience with our network that unless you've got massive amounts of coverage, people aren't interested. Now, of course, the problem we've got here is that you might say, yeah, we've got a device for tracking where your dog is. Well, people might buy one of them, but then they want to make sure that you've got coverage.
Yeah.
And who do they complain to if the coverage goes off air? They can't come to you, Nick, and say, where's my coverage gone?
Yeah, your hotspots in San Diego aren't providing my dog coverage in Birmingham.
You know what I mean?
Yep.
So there's no one they can go to and complain to the CEO or whatever, whatever. So it's kind of a different concept as to, whether devices, how big will they be,
Yeah.
So and how well they, how many comes on the network will then determine the interference. So
yep.
If it is going to be a problem, I don't think it'll be for years and years. So
and there's
not
not
something I bother about at the moment.
There's not that many transmissions from the hotspots. I can't imagine. And I can't imagine they all beacon at the same time. So it's not like they're all hitting. They're all beaconing at different times. Okay. So not a big deal. The last thing that I get a bunch of questions about is this idea of a high gain giving you longer range. Is with clear line of sight, I've seen on my 3 dBi antennas over water, kind of best case scenario, I've seen it hit 200 kilometers away. Now that's another gateway. Who knows how big that antenna is, but my gut feeling is that as long as there's clear line of sight, you don't get any more useful range with a high gain versus a low gain. Now I could be totally wrong on that, but yeah, tell me how you think about kind of the range and the gain piece and how those two work.
The ranges are amazing. When we did the testing of the drive survey testing of our network, drive testing being you'd stick a little test device like these ones here, stick it, connect it to a laptop and whatever, go taking measurements. And when I was checking all the logs that we recorded from that, I thought there'd been a mistake. I thought there's what was going on, because we had some sites in Birmingham, which is in the middle of the UK, and we were surveying a city called Bristol down in the southwest. And that was about 120 miles away, which is, what's that? I don't know, 150, 180 kilometers or something. Yeah. So, I was absolutely amazed at the distance. And of course, as I said, these were 9 dBi antennas. I don't know how high the site was that recorded it, but it was probably a 20 or 30 meter site. So those sort of distances are amazing. But that's on the uplink. Those are messages transmitted from these devices and received by those sites. And of course, at the moment, it's all about the downlink coverage from your beacons. But of course, your question would be: would we pick up those same signals 120 miles away if instead of 9 we had a 3 dBi antenna? Well, maybe, but it depends, because what you find with any cellular technology, as you reduce the signal level, it's not a case of signal works, signal stops. It's kind of a degradation in performance. So if you send 10 messages, great signal, you'll receive 10. With zero coverage, you'll get none of the 10. But somewhere in between, where you're on that borderline of whether it should work or not, then you might only get 5 out of the 10. And so when you say whether it'll work or not, well, the 3 dBi antenna, you may receive 4 or 5 of those 10 messages. With the 9 dBi, you'll get 10 out of 10. And so, in terms of earnings, you probably maybe get a bit more consistency or whatever by having the high gain antenna. But you're more likely to have a difference with line of sight than you are non-line of sight, where you're getting multipath and fading. That will make a difference. And certainly the electrical tilt will make a big difference.
Yeah, no, I'm going to go check out some electrical tilt antennas after this. I'm all fired up now.
Yeah, I'd be interested if you find some and what sort of price they are. So, you let us know, because I'll be very interested.
Yeah, I'll dig around. Well, I'll see. And have you worked at the multi-polarized stuff at all? Have you seen that? Have you played around with that?
What was that, sorry?
The multi-polarized antennas, like the H antenna?
Multi-polarized? No. We generally... Polarization is all about what you're transmitted on. If your transmitted antenna is vertical polarization, kind of 0-90, then certainly on line of sight, you want to use the same. Cellular is plus minus 45. So, antennas, that's what the masts use. So any masts, your external antennas at home should also be 45, plus minus 45. So yeah, whatever one mine is using, the others should as well, really.
I'll see if I've got an extra one in the garage. If I do, I'll send it out to you. You can test it. Let me know what you think. I sent one to...
Yeah, I'll be very interested, yeah. You pay postage, though.
Yeah. No problem. I mean, this stuff is also interesting, and I think what we're seeing is it's this merger or this intersection of folks like me who are just enthusiastic and trying to learn as fast as we can, and folks like you who are super professional. And always at that merger, always at those edges are new ways of thinking. And a lot of them can be wrong, right? As I come up with like 9 or 10 ideas, and 8 of them might be whatever. 3 of them are flat out wrong. 4 of them are pretty good. 1 or 2 are like, oh, we hadn't seen that before. And certainly I'm not saying that about multi-polarized antennas, because it's not my idea. But it's always cool to spread that info up and see what you think. Yeah.
Definitely is. So, because
if I got an extra one rolling around, I'll blast it out to you, and that'd be pretty cool to see what you think. Because I know, let's see, you test antennas on your channel. You've tested a couple, like the pointing cell antennas, and you'll help people like make a decision about, hey, should you spend 90 or 50 or whatever it is, right?
Yeah, just starting out to do that. Yeah.
Okay.
But experience is so valuable, and spreading knowledge definitely is. It's all right me saying, I'm a pro or whatever. But if you got people out there that have got loads and loads of experience with a load of technical, equipment like spectrum analyzers or vector network analyzers and whatever, then I could hardly go to you, you're wrong. If they've got tons and tons of evidence. I may be able to explain what that evidence is and analyze the data as much or better. But at the end of the day, you can't argue with like test results and evidence and stuff. So, it's all good.
No, 100%. That's the thing with this one hotspot that I'm always banging on, is it's on top of a mountain. It's got a 3 dBi antenna. For a while, people were saying like, oh, the only way you can earn is with the high gain antenna. It's the highest earning hotspot out of 9,000 hotspots in San Diego. Like you really? Just like you said, you can't just argue with the data. Could it be higher if it had a higher gain? Maybe, but possibly. It just indicates to me that at least in Helium, when it comes to earnings, and it's difficult to separate the two as far as kind of network performance and earnings performance. But on the earnings performance side, I just don't see that there's a huge difference between high and low gain. But people will swear up and down that I'm wrong, but that's just one.
I'd be very interested if you, I presume it's via an Omni antenna, if you got hold of a antenna with some electrical tilt, what difference that would make. And then if you did, then I'd be very interested to see what results they are.
Yeah. So I had
if it turned out to be less, then I'm going to look like a bit of a fool, aren't I?
No. I think that's the other piece with RF is it's weird, right? Like we don't have a perfect understanding of it yet as far as the real world, because there are so many variables. I mean, on this same site, I had a 13 dBi antenna, an 𝐿COM directional, big sector antenna. And at the time I put that in, there wasn't anything behind that antenna, and it provided like a giant swath of coverage.
Yeah.
And then I was really curious about this. And also at the time, that was too hot of an antenna to fall within FCC regs. And so I had to use some software to dial it down.
Yeah.
POC V11 is the thing that kind of changed all of that. And it did that automatically. And so I thought, why don't I just switch it out for this, basically the opposite, a really low gain. So I went from 13 dBi down to a 3 dBi. And I didn't see any change in the earnings. And I didn't see any big change in the coverage. What I'm seeing now is that there's not as many really long shots, but there's still long shots. And those long shots are, the way I think of it, like, they're just ridiculous. They're too long to be of use when we come to building an actual useful sensor to gateway network. They're sexy for gateway to gateway, but it's not actually useful.
Yeah. When you say that there was no change in coverage, is that based on the signals reported by the other miners, or is that via kind of tests and measurements?
No, exactly. That was the pattern that I see in the witness beacon. So when it pushed out a beacon, when it got witnessed, and that used to be able to see that on Explorer. I think Explorer has now switched it, so you only see the stuff that, because I always get this backward, that you've witnessed. But on a couple different tools like Helium Vision, you can see it both ways, what you've witnessed and what's witnessed you. And I just didn't see over the long run, over a 7-day period or a 10-day period or whatever you looked at, there just wasn't a big difference in the gateway to gateway communication, at least the distance.
Because, what I would then be interested in is, that's maybe a bit kind of against what I would think, but you can't argue with the data. So being very data analytical, I'd say, well, let's try and understand why that is. And if we can understand why that is, maybe we can make a change and make even more money. So,
Well, I mean, maybe what I'll do then is, I've got the little 𝗪𝗏 tester where you can fire out a beacon. I won't carry that 13 dBi out again, because it's a long hike. But I can carry out like a 9 and a 6 and a 3 and just sit in pretty much the same spot and fire off 20 or 50 beacons from each one and see what gateways pick them up and do a test there. I mean, I've done that on the roof. That's really easy, just to hike up or get on the roof of my house. But that might be the closest I can come to any kind of reasonable test for you.
Yeah, that's cool. Well, I've seen guys online doing testing all different antennas and found there wasn't that much different when they're high up, and others that have seen quite a considerable improvement. So that's the problem with only having individual people online. That's just one example.
Exactly. That's totally 100% on board with that. Yep. Because it's just one thing that's just anecdotal evidence that is not science by a long shot. So cool, ripping. So where can people find you? You've got a YouTube channel, right? It's just Richard Edwards?
It is. It is. Yeah.
Okay.
Yeah.
And I'll put a link to that.
Doesn't look as professional as yours at the moment. It's just kind of starting out, but yeah.
No. I think this thing, like, we get this opportunity to spread information around, and I want to make it super clear that A, I'm not the only source of information, and B, sometimes I'm not the best source of information. If I can point people to you for specific RF questions, or to David 𝗚𝗏𝗀 down in Adelaide in Australia, who's another RF expert or antenna expert, you're like, I want folks to get the best information. I don't really care if it comes from me or not. So totally, people should check out your channel.
Cool. Yeah. And I have to say, your blog's very good. It's kind of, from what I've read at the moment, it's best source of kind of info I've seen. So that's a great.
It's not bad for an amateur. Yeah.
Yeah, definitely.
Cool. Richard, thanks a ton for your time, mate.
No problem.